Good morning, Algebra 2 class. How about a joke? How many apples grow on a tree? All of them. Ha 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 ha. Good morning. Hope you're having a good day. Go enjoy your apples and everything that you plan to eat today. And we're ready to have your math lesson for today. We're ready to jump into the wonderful world of adding and subtracting rational expressions. And yesterday we worked on multiplying and dividing them, so it only makes sense that we would move on to this. You have to remember that rational expressions are very much like regular old fractions, which means that you need to think about things like common denominator for adding and subtracting. We don't do that for multiplying and dividing like we saw yesterday. So here we have common denominators. So when you have common denominators, pretty easy. You just bring them together into one fraction and you add the numerators. Since this doesn't have any like terms, the numerators have to stay separate, and our simplified expression just looks like this. Okay? Here we have the common denominators. So when we put the numerators together because they're added, you do look for like terms. The 2x and the 7x can go together, and the -5 and the 1 can go together. So the numerator is 9x minus 4, and the denominator stays 5x plus 2, just like you do with regular normal fractions when you have common denominators. So that's pretty nice. When you see the common denominators, just do what you always do. The difficulty comes when you don't have common denominators because you have to make common denominators. And that's something that way back in the days of early fractions, you might have thought, okay, well, I don't really feel like learning this, or it was a little difficult, but we need to come back to it for our rational expressions. So we're borrowing from those same concepts in order to be able to add these two, because their denominators are kind of sort of the same, but not enough the same. We have to do something to it to make them match 100%. Okay, so I think what you'll find though is that it is slightly easier than when it's pure numbers. And so let's just jump right into it. So I need to make sure that I have the exact same thing in this denominator as in this denominator. This one has 3 x's and 1 y, and this one has 1 x and 2 y's. So in order to make them match, we're not going to be dividing numerator and denominator by anything. What we're going to be doing is we're going to be putting more things in to make sure that they're the same. So for example, if I put 2 more x's over here and I put 1 more y over here, I'll have x cubed y squared in both of them. Okay, so your job is to try to make the denominators match. So I need 1 more y over here and I need 2 more x's over here. But when you're doing that, in order to keep the value of this particular term the same, you need to multiply the numerator and denominator by the same thing. If you remember back to your days of equivalent fractions, because y over y is just 1, so really all I'm doing is multiplying this by a strange looking 1. And what this gives me is 3 x's and 2 y's in the denominator. When I multiply this one by x squared, I have 3 x's in the denominator and 2 y's in the denominator. So 3 x's here, 2 y's, 3 x's here, and 2 y's, all in the denominator. The numerator has to have the same things done to them that the denominators did because we need to multiply by 1. So we bring that together. This needs to get simplified to xy. This needs to be simplified into 5x cubed. And my denominators are now x cubed y squared in both cases. So then you need to bring it into one single fraction. You need to take your common denominator now and bring your numerator over. But what you have to do is now look to see if this thing can be simplified. So check out your numerator and factor out anything. Remember from yesterday's, you have to factor and cancel. Well, at the end, you always want to factor and see if there's anything that can cancel out. So there is a GCF of x in these two. So we'll bring that x out, because x times 2y is 2xy. X times 5x squared is 5x cubed. And then we have a factor of x, and when we have a factor of x, you can cancel it with a factor of x in the denominator. So one of the x's can cancel out here. So we're left with 2 x's in the denominator, and 2 y's in the denominator, and 2y plus 5x squared here. Okay, so first you need common denominators, then you put them together, then you check to see if there's anything that you can simplify at the end. All right, and that will be our pattern, but it gets more complicated as the numerators and denominators get more complicated. So stick with me. You really need to practice your factoring as well. Factoring is huge. If you haven't noticed in algebra, factoring is huge. So this particular section gives you also more opportunities to practice factoring, like yesterday's lesson did too. So let's look at this one. We need common denominators here, but it's not quite that simple, because we need to find the factored form of this denominator before we can figure out what we can multiply in. And we need to recognize that this is a group. This is really 1 times x minus 1. So that's fine. So let's think about our factored form of this. Factors of 2, that when you add them you get -3. So -1 and -2 fit that bill. And so we factor it out and we get that. Okay, now we need to think, if this is put together, if this is one unit all itself, it's its own binomial, we need to make these two match. This one already has an x minus 1, so that's encouraging. I don't need to change this at all, but this one needs an x minus 2 to go with it in the numerator and the denominator. Okay, so here we have this. The x minus 2. The x minus 2 will make that denominator match the other denominator. And that's our whole goal, is to make this part and this part be exactly the same. Once you have common denominators, then you can put it together. But we do need to keep in mind that you need to do a little distributing so you can put the like terms together. So before I put those whole things together, x times x is x squared, x times 2 is 2x. 2x minus 1 you leave alone. We do have our common denominators. So now I can put it together by addition. Notice that my negative 2x and my positive 2x cancel each other out, so you're left with x squared minus 1. Now that it's together, you look to see if there's any factoring that you can do in the numerator. Notice that I didn't go ahead and multiply this denominator together yet. Don't do anything like that till the very end, because there might be another canceling step, like right here. X squared minus 1 is the difference of 2 squares. So when you factor it, you get x plus 1, x minus 1. And I'll get these out of your way. Okay, there's our factored form. And then what you notice is that there's x minus 1s can get canceled out. So we're canceling out our x minus 1s. And then all you're left with is x plus 1 over x minus 2. That's as simplified as it can get, which is pretty much simpler than this up here, so that's good. But you also have to think about restrictions. Just like we thought about restrictions for the multiplying, you have to think about the restrictions. So if we go all the way back up here, x is not allowed to be 1, and x is also not allowed to be 2. X not equal to 1, x not equal to 2. I'm not thinking about graphing or anything like that. I'm just thinking about simplifying these expressions. So x can't be 1, x can't be 2. It's our restrictions, but our answer is right here. X plus 1, x minus 2, that is your answer. All right, let's look at another one. Okay, common denominators. This looks kind of promising, kind of like there's some things that look like they're going to be in common. That's good, but we need to figure out what it is. So what we should do is start by factoring those denominators, because when you factor everything, really anything that can be factored should be factored at the beginning, whether it's numerators or well, not numerators, denominators. Any denominator that can be factored should be factored so you can find a common one. So here you have a GCF of x. Let's factor that out. Notice that I'm already starting to think of the x plus 2 as a group, because that might be helpful to us. 2x minus 4, that can be factored. There's a common factor of 2 in there. So 2 times x minus 2. Now that's going to help us to figure out what's needed to make these match. Both of them have an x minus 2. They don't need that. This one has a 2. This one does not have a 2. This one has an x. This one does not have an x. So this one needs a 2. Always doing that thing over itself. And this one needs an x. So that now both of them will have 2x, x minus 2. 2x, x minus 2. And thinking of these things as their own group makes it easier for us to realize we need to multiply that in. Our denominator we're going to leave in factored form, but the numerator, in order to combine it, needs to be multiplied in. So this would be 2x plus 4, and the other one would be x squared plus 2x. Now, when you put these together, okay, we have our common denominator that we're going to leave alone. But when we put the numerator together, watch out for this minus. This subtracting is a little bit dangerous, because this subtracting needs to get distributed to both of the elements in the numerator. Okay, once again, watch out for this minus, because this minus needs to get distributed to both of the pieces, both of the terms in the numerator. Minus x squared minus 2x. So we're going to put them all together, put our like terms together. Well, wait a minute. 2x and 2x, 2x minus 2x, that's gone. So I have this. Now we need to factor. Remember, if we have a minus out front, you always want to factor out a negative 1. So we will do that. And when you factored out a minus 1, what becomes revealed is that we have a difference of 2 squares. So this is x plus 2, x minus 2. And the great thing about that, let me show you. There we go. There's our x plus 2 and our x minus 2. Just putting it in factored form. But then what that reveals is that you've got an x minus 2 in numerator and denominator, which can be canceled out. There we go. So we're left with this part. The negative 1, x plus 2, nothing else can get canceled there. 2x in the denominator. To make it look a little better, you distribute that negative 1 back in. So you have, there's your answer. Oops, I'll get this out of the way. Right along with the restrictions. Your answer is negative 1 times x minus 2. Now you can distribute it back in, or this should be negative 1 times x plus 2. You can distribute it back in or not. Okay, negative 1 times x plus 2 over 2x. And x can't be 0. If we go back to here, x is not allowed to be 0, and x is not allowed to be 2. So negative 1 times x plus 2 over 2x. If you want, you can distribute that in and get negative x minus 2. Okay, so there's your answer right there. Okay, excellent. Let's move on and keep on going, because sometimes you can get some strange looking fractions, complex fractions. This is really the same exact thing. It's a division problem, though, combined with things needing like terms. So this one, if you'll notice, has all numbers. So we're going to use this as a review of how to deal with numbers, and then we're going to break it down and show how this applies with yesterday's lesson for division, but then today's lesson with watching out for denominators and those type of things. So this is kind of a combination, which complex fraction, sure. It's got a rational expression in the numerator and some kind of a rational expression in the denominator as well. So let's deal with just plain old fractions first of all. You're going to want to think about the numerator and the denominator separately. So when we think about the numerator, 1 minus 2/3 is 1/3. Okay, but you can do that by finding common denominators. 3/3 is 1 minus 2/3. 10/5 is 2 minus 1/5. And some of you might find it even more difficult to do the regular numbers than the rational expressions. So we'll see how that goes shortly. So we have 1/3 over 9/5. This is a dividing sign. So after you've simplified numerator and denominator, notice I said after you've simplified numerator and denominator, turn it into division like this. And then remember that your rule for division is that you flip the second one. Keep the first one, change and flip. So times the reciprocal, like that. Okay, now like I said, some of you might even actually find this, because of the plain numbers, a little harder. Your calculator can actually handle that for you, but it's a real maze of putting in parentheses in the right places. So what we need to do now is we need to take a look at what happens when you have something more complicated looking, but having variables, but you can handle it. What you want to do until you have the numerator completely simplified and you have the denominator simplified, kind of ignore the other part. Think of it as two separate problems that you need to simplify first before you can do anything with this dividing bar. So let's just concentrate only on the numerator for a minute. You need common denominators up here. So this one needs a y and this one needs an x. That one needs a y and that one needs an x. So that right in this part you have an xy in the denominator. I'm going to continue to ignore this part and just work on the top. Now I have y over xy and I have x squared over xy. I went ahead and put them together because they're already like denominators, so you can put them together. And I have this now as simplified as it can get. There's no factoring and canceling that's going to help us with this. So I've got my numerator handled up to this point. Now I want to handle the denominator. This is 1 over 1. So I need a y in this denominator. So that when I have common denominators of y, I have 1 plus y in the numerator and y in the denominator. So now I've handled both the numerator and the denominator separately. So I want to rewrite this with the dividing symbol because this is too much with all the fractions. So I'm going to rewrite it here. It doesn't do you much good to do the rewrite until you've handled these, because then you have big parentheses to deal with, and what I found that it's just hard to deal with it that way. You can if you want to, but it's just hard to deal with it that way, because now since you have a fraction here and a fraction here, when you've converted it into a division problem, you can multiply times the reciprocal very easily. And when I've multiplied times the reciprocal, what I can find out is my y's can cancel. There's nothing else here that's going to cancel out. There's no more factors. I have x times 1 plus y here. And I can multiply that out. So you have something that's completely simplified. If we wanted to check and make sure that we had, like watch out for numbers that you can't have, and I haven't done this on this one, but you would say x can't be 0, y can't be 0. And also we have this little one that is hiding here. Y can't be -1 also. That's just kind of a little extra thing to throw in, but this is your answer right here. All right, one more, and then we're done for the day, except for you're going to go and you're going to work and practice these things and do assignment 104. Okay, and that'll be the rest of your work for the day. Let's take a look at one more. Once again, there's a numerator problem hiding and a denominator problem. So we want to treat the numerator as its own problem first until we've got that one handled. I have an x and I have an x plus 1. This part needs an x plus 1 and this part needs an x. Okay, this part needed an x plus 1 and this part needed an x. I'm ignoring my denominator. I want to put these things together. So I'm going to multiply out. We need to multiply out x squared plus x minus 2x minus 2 plus 2x over x times x plus 1. Then I can simplify this. My like terms, -2x and x cancel each other out, but I have x squared plus x minus 2 left. And x times x plus 1. I have now handled my numerator to the point where you've got it all as its own fraction. So let's now handle the denominator. And I've got these little pieces that I can drag out of the way, but you might want to even physically use a piece of a note card or something like that, so you're focusing on just one thing at a time. We're focusing now on this. This one has an x minus 1, this has an x plus 1, neither one is factorable. So this one needs an x plus 1 over an x plus 1, this one needs an x minus 1 over an x minus 1 to make them match. Okay, this one needed an x plus 1. And this one needed an x minus 1. We need to be careful when we're handling this. We need to distribute. And so there's that part. I am combining it already into my like denominator here. But I've got 3x plus 3, then you're distributing the -1. So -x plus 1, be careful with that. Then we put 3x minus x gives you 2x. And 3 plus 1 gives you 4. And I have this. All right. Notice I didn't go ahead and multiply out my denominators because it's going to be much more convenient if I can keep them when we get to the dividing stage. I want this big fraction bar to turn into dividing. Actually, we turn it into dividing and then it can turn right into multiplying. This is divided by this, so I can multiply times the reciprocal here. And If you need to write the dividing step in, write the dividing step in. I did this in the interest of space, but if it bothers you and you're not quite sure, remember this divided by this means you take times and flip over this denominator. Right off the bat, the x plus 1s can cancel out. So we can get rid of them. But what we're left with needs to be factored. X squared plus x minus 2 can be factored to x plus 2 and x minus 1. This has a common factor of 2, so that can be factored out. You need to do those things. Get rid of it. Oops. There we go. These, let's see. Here's your factored form. We factored this one and factored this one. Now x plus 2's can cancel. Okay, the x plus 2's can cancel out. These can't cancel because you don't have a numerator and denominator. But what you can do is you can multiply them. X squared minus 2x plus 1, or if you want to consolidate it into x minus 1 squared, that's also perfectly fine, because we have simplified it down as much as we possibly can. There's nothing else that will cancel out, so this one can be done. All right, so that's it. That's all that you need to be able to do. Get to work on your assignment and get ready to have a good, relaxing Memorial Day weekend. I hope you find something fun to do. Have a great day, and God bless you.